Spanning a 7-year production life, the 4th generation BMW 3 Series, also known by its engineering designation as the E46, came equipped with 8 unique engines. Ranging from 1.6 litre 4-bangers to 3.2 litre 6-cylinder screamers, there's an engine for every driving style and usage. In this video, I hope to cover every single engine ever fitted to the E46 lineup, as well as break down exactly where they came from, their issues, their strengths, and what you, as a DIY mechanic, need to know about owning one. Found in 316 and 318i models from 1998 to 2001, the M43B19 was carried over from the outgoing E36 for the early production models of the E46. Producing 103 horsepower in the 316i and 117 horsepower in the 318i, the M43 doesn't rank highly when it comes to overall performance. Starting life in 1991, the M43 engine came in displacements between 1.6 and 1.8 litres in the E36, but was bored out to 1.9 litre for its application in the E46. All models feature a single overhead cam, 2-valve per cylinder valve train, with a cast iron block and aluminium head. Though the same engine was used between early 316 and 318i models, they differ in 2 places. The first being that for the lower power 316i, a custom, smaller camshaft was used compared to the 318i, which used the same camshaft that came in the earlier 1.6 and 1.8 litre variants. The second difference is the application of a dual-length intake manifold, also known as a dicer, exclusively in the 318i model. The dicer valve fitted in the 318i allowed for higher torque output under 3,700 rpm by closing its valve, causing incoming air to be restricted before entering the intake runners, leading to an increase in air velocity. This increased air velocity leads to an increase in pressure within the intake manifold, meaning that once any given cylinder begins its intake stroke, more air enters the cylinder and a larger explosion is produced. At higher RPMs, typically around 4,100 RPM, the dicer valve opens, allowing for a greater volume of air to enter the intake and thus for more horsepower to be developed. As both 316 and 318i use identical engines save for the 2 differences, it is completely possible for a DIY mechanic to upgrade the 316i variant to the 318i. As the camshaft used in the higher power model is the same as any other M43 that came before it, they are widely available for non-wallet breaking prices. The intake on the 316i even has the mounting position for the dicer valve, though from factory it is blanked off with a plastic plate. The trickiest part being connecting the dicer valve to the engine computer, necessitating either a reprogram of the ECU or a retrofit from a donor 318i. As for reliability, the M43B19 redeems itself due to its relative simplicity. The low amount of electronic integration compared to its successors mean that there are less systems to go wrong, and being an iron block engine, is more resistant to warpage due to overheating. The engine, however, is not completely free of flaws. The dicer valve fitted to the higher power 318i is to be considered a wear item, and upon failure leads to poor running. Valve cover leaks are also a common issue, as well as overheating, though these 2 issues are typical in any petrol-powered E46. Spun crankshaft bearings are also an issue that may arise from examples which have been driven hard, but providing maintenance is kept to, should not present itself in most cases. In my opinion, the M43 is a very much jack-of-all-trades, though master-of-none engine. What it lacks in outright performance, it makes up for in simplicity and reliability. Being an iron block engine, turbocharging is a viable path to increasing horsepower, though its small displacement and 4 cylinders will forever cement it nearer the bottom of the E46 engine leaderboard. Coming in as the successor to the outgoing M43, the N40/N42 was fitted to the 316i between 2001 and 2004, and to the 318i models between 2001 and 2005. As with its predecessor, both 316 and 318i models were fitted with the same engines, though this time BMW opted to differentiate the 2 through displacement rather than power output. The 316i was fitted with a choice of 2 variants. The standard N42B18, the 1.8 litre variant producing 114 horsepower, or the much rarer N40B16, a 1.6 litre producing a similar 115 horsepower. Though these 2 variants are officially separate engines, the N40 is actually just a 1.8 litre N42 with a reduced stroke and deleted valvetronic system, though instead carries over the dicer system found in the earlier M43. Its rarity stems from its application. The N40 was only offered in a few select markets which favoured sub 1.6 litre engines due to tax regulations. As for the 318i, it received only one variant, being the N42B20, a 2 litre producing 141 horsepower. The N42 was an E46 exclusive, being produced in only 2 variants, 3 if you include the N40 offshoot. When it hit the market in 2001 as a successor to the aging M43, its on-paper credentials promised a generational jump. Upgrades included going from single overhead cam to dual overhead cam design, doubling valves per cylinder from 2 to 4, as well as introducing BMW's famous Vanos on both cams and Valvetronic systems, which operate in symbiosis to change valve lift and timing according to the running conditions. Block material was also changed from cast iron to aluminium, reducing weight over the front axle and promising improved handling over its outgoing predecessor. However, it quickly became apparent once these engines hit the road that BMW was still some ways away from their high-tech dream engine. For one thing, the timing chain tensioner, responsible for keeping the chain, which drives the cams under tension, was initially too weak and short. This means that for especially earlier engines, the timing chain was more prone to skipping teeth, and due to the N42 operating as an interference engine, would lead to bent valves if not promptly taken care of. The Valvetronic system, which operates through actuating a servo motor connected to a third eccentric camshaft to vary the lift allowed by the valves, is also essentially guaranteed to fail before 150,000 kilometers. Fixing said system usually involves the replacement of the servo motor, though it is not uncommon for failure to also stem from leaking valve cover gaskets, allowing oil to seep into the eccentric shaft sensor connector, leading to failure. Another fun quirk of the Valvetronic system was its effect on vacuum generation. In cars, a vacuum is needed for operating the brake booster, a device that amplifies torque through the brake pedal, which in turn makes operating the brakes far easier. Usually, this vacuum is provided from the intake manifold, where the throttle plate acts to restrict airflow, whilst the engine continues to suck in more air, resulting in a partial vacuum inside of the space between valves and throttle body. With the introduction of Valvetronic, the engine's air intake and thus its speed can be controlled using the amount of lift the intake valves have. This completely negates the need for a throttle body, but in turn also removes the ability to generate a vacuum within the intake manifold, requiring an additional vacuum pump to be installed to work the brakes. This additional component increases weight, drag upon engine and complexity, and as you can imagine is not typically very reliable. The quirks don't stop there, however. Despite now not requiring a throttle body, the N42 in fact still has one. Acting as a backup throttle in the likely event that the Valvetronic system fails, it stays open during operation, only closing on startup to create an initial vacuum until the auxiliary pump takes over. Luckily though, the N42 is not all doom and gloom. Compared to its predecessor, the bump in horsepower and torque in both the 316 and 318i is very much noticeable. The additional systems as well as valve train overhaul also means that the N42, when running correctly, is sportier and more responsive, with the 2-litre variant in the 318i being praised for its fun factor. Much of what has been said may be applied to the 1.6-litre N40, though its omission of the Valvetronic system means that, in theory, it should be more reliable than its larger displacement siblings. Sadly, however, the N42 proved to be too deeply flawed, and was discontinued before the end of production of the E46 generation. Being the first BMW engine ever to be fitted with the now famous Valvetronic system, its failures gave us the legendary engines BMW makes today, though those who adopted it first are left with an uncomfortably large repair bill. In my opinion, the N42 and its runt brother, the N40, are hard to like. Being a 4-cylinder, it is still dwarfed by its 6-cylinder brothers, who are both more reliable and more powerful. Its leaky nature and overcomplicated design lead to far more often repairs than should be expected of it, and though it can prove to be halfway reliable with proper maintenance, more often than not these engines find themselves locked up in scrapyards. The additional emission control systems that had to be fitted further increase complexity, and make any serious modifications both risky and complicated. Although I have listed the N46 as its own separate engine, in reality the N46 can be considered a refresh of the outgoing N42 engine. Though sharing the same blocks and displacements as its predecessor, the N46 received a revised crankshaft, intake manifold, and rollers in the valve train, as well as moving the previously external Valvetronic system internally. Like the N42, the N46 came in two guises for the E46 series, a 1.8-litre unit and a 2-litre unit, fitted to a 2004 onward 316i and 318i models respectively. The 316i variant produced an identical 114 horsepower compared to its N42 predecessor, though the 2-litre unit found in the 318i bumped power up to 150 horsepower, a whole 9 horsepower more than the former design. Reliability-wise, the N46 fares slightly better than the N42, enough so that BMW used the N46 and its later revisions until 2015, though still carries many of the same issues that plague the N42, including valve stem seals perishing and allowing oil to be burnt Valvetronic and Vanos seal failure causing poor idle and running conditions, as well as various sensors critical to engine control failing easily due to oil leakage around different points of the engine. Timing chains are also reported to be a common issue, with stretched chains being par for the course as these engines grow older. As for driving experience, owners report, similarly to the M42, that the M46 is rather sprightly in its 2-litre guise, and providing the numerous cam timing and actuation systems are functioning correctly is both fun and economical to drive. Another positive of the M46 compared to the M42 is the lifespan of the engine. Due to the drastically longer production life of the M46 and its iterations, both parts and information for the engine is much more readily available. Modifications are also better documented, such as upgrading the engine control unit to one found in later iterations, resulting in a bump of power up to 170 horsepower from the 2-litre unit. In my opinion, the M46 still very much lives at the bottom of the pecking order. Its and predecessors' penchant for leaking oil does nothing to help the stereotype of BMWs being unreliable, and its complexity, coupled with an uninspiring engine note, mean that it struggles to sway used buyers away from its more enticing 6-cylinder counterparts. Having covered all the 4-cylinder petrols, it's now time to cover the 6-cylinder units, starting with the M52 engine. Originally being fitted to the previous E36 series, the M52 was carried over and updated for early models of the E46, with it being equipped on models between 1998 and 2000. The M52 came in 3 forms on the E46, a 2-litre variant found in the 320i, a 2.5-litre variant found in the 323i, and finally a 2.8-litre found in the 328i. All variants found on the E46 are dual overhead cam, 4 valves per cylinder engines, with the differences lying purely in displacement. During the carryover of the M52, the engine was also updated compared to its previous iterations found in the E36. It received a dual Vanos system, allowing for variable valve timing on both intake and exhaust camshaft, as well as the addition of the now infamous dicer valve. It also received a redesigned throttle body, which incorporated a motor for actuating the butterfly valve via the newly introduced active stability control system, though kept the original cable linkage between the throttle pedal and throttle valve. Unlike its original iteration, all M52 TU engines came as aluminium block engines. Previously, on its original design, the M52 came as an iron block engine for the North American markets and as an aluminium block for the rest of the world. This was due to the higher sulfur content found in petrol in the US and Canada, which had a corrosive effect on the Nickel layer of the cylinder liners in the engine. The M52 TU replaced these Nickel liners with iron ones, rectifying this issue and allowing for all M52 TU engines to come with aluminium blocks, regardless of country, saving an additional 23 kilograms compared to the outgoing iron block. All 3 variants have healthy power outputs, with the 320i, 323i and 328i making 148, 168 and 190 horsepower respectively. The M52 engine fitted to the E46 lineup is specifically the revised M52 TU variant, differing from its original design through the incorporation of a dual Vanos system, replacing the previous single Vanos which had acted only upon the intake camshaft. The M52 TU can essentially be considered a hybrid between the original M52 engine and its replacement, the M54, with its core being an M52 block, but with a more or less identical head to its successor. Reliability-wise, the M52 variants found in the E46 range are considered to be very reliable, with examples regularly being able to exceed 300,000 kilometers with only basic maintenance. Being an aluminium block, these engines are slightly more susceptible to block warpage due to overheating, though this can apply to any other aluminium block's engine. The only major issue that can affect these engines is the infamous Vanos system, again stemming from perished seals that can lead to poor running and loss of power in either the bottom or top end RPM ranges. Another flaw, though not directly due to the engine's design, is the infamously poor cooling system found in the E46 series. Though not as big of an issue for the lower heat output engines, the cooling system found in all E46 models is made predominantly out of plastic and is prone to failure, especially when pushed hard. Overall, however, the M52 TU variants found in the E46 lineup are very stout engines, with great reliability and sound. Modifications are also abundant for this engine, with common upgrades including swapping in the higher flow intake manifold from the later M54, netting a general gain of around 15 horsepower depending on variant type. The M52 TU is also a popular target for supercharging, with its iron sleeves allowing for power in excess of 250 horsepower, especially in the 2.8 litre variant. In my opinion, the M52 TU variants fitted to the E46 generation are one of the reasons why the E46 is still considered one of the best driver's cars of the 2000s. Its mid to top end grunt, as well as amazing soundtrack, is a pleasure to drive, and its surprising reliability coupled with the expansive modification lists means that even a novice mechanic is not out of their depth working on these engines. Replacing the M52 series of engines for the 2000 model year, the M54 engine can be considered to be a full overhaul of the outgoing M52 engine. Block and head stayed relatively the same, though through some deboring, the outgoing 2 and 2.8 litre variants were bumped up to 2.2 and 3 litres respectively, with only the 2.5 litre variant retaining its original displacement. Other changes include the removal of a physical throttle linkage, replacement of the fuel delivery system to a non-return system, upgraded Siemens MS43 engine management system, as well as the installation of a revised intake manifold. Power was also increased across the board, with the 320i, 323i and 328i becoming 320i, 325i and 330i, making 168, 189 and 228 horsepower respectively. The latter 330i model is also notable as being the highest power non-M E46 model that BMW made, with its North American exclusive ZHP edition making 235 horsepower, owing to a reprogram of the engine management system and more aggressive camshafts. Reliability was thankfully carried over from its M52 origins, though an uptick in valve cover gasket leaks as well as water pump failures has been noted. Diagnosing of the M54 is however easier compared to the M52, owing to the unified CAN bus interface becoming standard, replacing the split body engine system found in the M52 engine. Modifications-wise, the M54 lives up to the outgoing M52. ZHP camshafts and a computer reprogram allow for any 330i to gain the 10 horsepower that the factory ZHP models came with, and along with a catalyst exhaust and N54 intake manifolds, 250 horsepower is fully within the capability of this engine. In my opinion, the M54 variants found in the E46 are fully capable replacements to the M52, retaining, if not improving, the driving experience presented by its predecessor. All three variants offer an excellent driving experience, with the 330i being nigh on the closest you can get to M3 performance without paying M3 prices. Mechanically, it is still easy to work on thanks to its M52 roots, though with the addition of a few more sensors, electrical gremlins may be slightly more common. Now, the M56 comes in an odd place. Though technically a different engine to the M54, it is essentially a 2.5 litre M54 engine, with modifications made in order to conform to the super ultra-low emission vehicle laws in the US states of California, New York, Vermont and Massachusetts. The M56 develops 184 horsepower, a 5 horsepower decrease to its base configuration, with this power reduction originating from the extensive emissions equipment fitted, including a redesigned intake manifold with integrated hydrocarbon block, full stainless steel fuel system including injectors and fuel rail, stainless steel fuel tank with monopiece glass encased fuel pump and filter, redesigned aluminium valve cover with integrated crankcase ventilation system and redesigned injectors with a 4-hole design. Rollout of the engines was from 2003 in the states of Massachusetts, California and New York, and from 2004 in Vermont. Though performance of the M56 is comparable to the 2.5 litre M54 on which it is based, buyers should be aware that the added emissions equipment both increases the rate of failures as well as cost of repair. One of the most common problems reported is that of the fuel pump/filter failure, which due to their complete integration into the stainless steel fuel tank necessitates a full fuel tank replacement if either part fails. This job is easily between $6,000 to $8,000 for parts and labor, with other components exclusively found on the M56 being both expensive and in low supply. In my opinion, though based on a great engine, the additional emissions equipment added on both reduced driver pleasure and increased complexity of the engine. Being so DIY unfriendly, as well as the extortionate prices for failure-prone parts, mean that the engine was effectively kneecapped from the factory. The saving grace being that due to its M54 base, many parts are interchangeable with the aforementioned engine. Though due to the extensive re-engineering of the M56, swap-outs may not be as straightforward. Finally, we reached the zenith of the E46 engine lineup, the legendary S54. The S54 was installed in the E46 M3 from the year 2000 to 2008. Being the largest engine fitted to the E46 generation at 3.2 litres, the S54 is remarkable in that it is not in fact based upon the M54 engine as the name would suggest. Instead, the S54 shares more similarities with the previous generation E46 M3 S50 engine, notably the iron block and displacement. It features the same dual overhead cam 24-valve setup as the M54, but with a higher 8,000 RPM redline, giving us one of the most iconic sounds in automotive history. Compared to the outgoing S50, the S54 features revised camshafts, finger-style valve actuators replacing the bucket and tappet style found before, electronic throttle control, as well as a scavenging oil pump, allowing for constant oil circulation throughout the engine, even under heavy cornering conditions. All of these improvements allow the S54 to develop 338 horsepower in European models and 333 horsepower in North American models. In 2003, the S54 received a high-power variant to power the now legendary E46 M3 CSL, developing a boosted 360 horsepower owing to an upgraded carbon fiber intake manifold, aggressive camshafts, and lightweight exhaust manifold with a straighter exhaust exit path, a feature carried over to later model S54 engines found in the regular M3. The S54 HP also strangely uses a MAP sensor in the place of a MAF sensor found on the standard variant. The manifold absolute pressure sensor used is unusual in that its application is primarily found in forced induction engines, as it's a method of calculating airflow into the engine depending on the pressure inside of the manifold, due to the speed of incoming air, rather than assessing the volume of air entering the engine like a mass airflow sensor. The result, however, speaks for itself, with the S54 HP found in the CSL being the most powerful engine ever fitted to any mass-produced E46. From a driver's perspective, the S54 is often considered the engine powering the best M car BMW ever made, with its punchy, linear power delivery and 8,000 RPM redline being called
BMW at its absolute best.
Reliability-wise, the S54 is roughly on par with the other 6 cylinders, and with an upgraded cooling system, has far less issues than with the common cooling system failure points experienced by the standard models. It can, however, be noted that due to the much tighter tolerances and already best-in-class power-to-litre ratio, power modifications tend to be riskier and overall reduce the reliability of the engine. Still, providing precautions are taken, a well-maintained and modified motor is capable of producing 450 horsepower before major issues start arising. In my opinion, the S54 really exemplifies the best of BMW, with its high revving, naturally aspirated Screamer 6 being more akin to a motorcycle engine than an automotive one. Its relative simplicity, carried over from its S54 father, means that, though being a true motorsport engine, it is relatively easy to work on, and with examples regularly exceeding 300,000 kilometers on basic maintenance, will keep any owner grinning for many years. Though being pitched as being a different engine in the 318 and 320D, in reality, both models are powered by the same engine and variants, the 2-litre M47 turbo diesel. The M47 originally came out in 1998 with the release of the E46 generation, being loosely related to the outgoing M41 which it replaced. Unlike the M41, however, the M47 features a dual overhead cam 4-valve per cylinder valve train with direct injection, though retaining the single turbo setup. Models made from the 2001 model year received the updated variant, boosting power in the 320D up to 148 horsepower, but remaining at 114 horsepower for the 318D. The updated version differs from the original in a number of ways, those being boring out of the originally 1.9 litre block to 2 litres, addition of a higher pressure fuel pump, injectors and common rail injector system, as well as the inclusion of swirl flaps. The swirl flaps later added by BMW are a series of kebab-style flaps that are inbuilt into the intake manifold and were designed to remain half open at low RPMs in order to cause turbulence in incoming air, allowing for a more homogeneous mixture of fuel and air in the combustion chamber, resulting in both cleaner combustion and improved low-speed torque. Though mostly successful in this regard, the latest swirl flap inclusion is flawed due to the bolts, which hold the flaps onto the skewer, often vibrating out of their fittings and falling into the combustion chamber, causing serious damage to the engine internals. For this reason, a swirl flap delete is often high on the list of things owners of this engine do. It is also reported, however, that this issue is very hit or miss, with some also stating that their swirl flaps hold up even past 300,000 kilometers. Ultimately then, it is up to the owner to decide on whether or not said removal is warranted, as though a delete kit is inexpensive, the process itself is not quick nor easy. EGR valves too are reported to be a nuisance on the M47, with carbon buildup and sludge accumulation often causing the valve to stick open and result in poor acceleration and performance. Blissfully though, the M47 lacks the now infamous DPF, common in newer diesel vehicles, and therefore does not suffer from blocked DPFs and their associated drawbacks. Reliability-wise then, the M47 is a very stoutly built engine, with an iron block and aluminium head design being over-engineered for its factory power output. Aside from the aforementioned faults, the M47, when duly maintained, is a very long-life engine, with some owners reporting mileages well over 400,000 kilometers. As for driving experience, the M47 is very sufficient. Though grunty enough, especially in the 320D, the comparably boring sound of a 4-cylinder turbo diesel leaves a little bit to be desired, and the heavier iron block engine means that the 50-50 weight distribution is somewhat compromised. The M47, however, does redeem itself in other places. For example, fuel economy in the region of 4 to 5 litres per 100 kilometers result in cheap running, and being that it is a turbocharged, intercooled diesel, a cheap chip tune can push 190 horsepower on stock internals. Modifications are also cheap and plentiful, with popular upgrades including fitting an operated intercooler from the 330D, bigger injectors from an E90-335D, and larger turbo, also from the 330D. These upgrades, coupled with the strength of an iron block and stout conrods, allow for the M47 to make up to 250 horsepower on stock internals. In my opinion, the M47 engine is one of the staples of the E46 lineup. Though not as exciting nor as nicely sounding as the largest 6-cylinder engines, its bulletproof design and great fuel economy has stood the test of time. With the 320/318D models it was fitted to being one of the most common to see on the second-hand market in Europe today. Though only producing a maximum of 150 horsepower in its highest power variant, its grunty 330 Nm of torque still allows it to spin the rear wheels in the right situations, putting a smile on any car enthusiast's face. Overall then, the M47 is a general great all-rounder, with quality similar to the 1.9 PD TDI engine found in many of the VAG group cars. Saving the best till last, we have the M57 D30, found in the 330D. Coming in two variants for the pre- and post-facelift model, the M57 is essentially an M47 with two extra cylinders locked on, raising displacement from 2 to 3 litres. From 1999 to 2003, 330D models used the original M57 D30, pushing out 390 Nm and 184 horsepower. For models from mid-2003, the M57 was reworked as part of its technical overhaul, with displacement being bumped up to a full 3 litres, up from 2.9 litres in the original. Fuel rail pressure increased from 1350 bar to 1600 bar, as well as an update to the engine management from Bosch DDE4 to DDE5, resulting in the M57 D30 TU raising power to 204 horsepower and 410 Nm of torque. Like its smaller brother, the M47, the M57 shares the single turbos and valve train setup, though too unfortunately shares the same swirl flap issues. EGR valves are also reported to seize up due to excess oil and gunk accumulation, though a common and relatively easy upgrade is deleting the EGR valve through a blanking kit. Reliability-wise, the M57 is very much over-engineered for its stock power output, with examples in excess of 500,000 kilometers not being unheard of. Unlike the later versions used in the BMW's F-Series bodies, the only variants fitted in the E46 330D lack much of the emission control equipment such as AdBlue injection and diesel particulate filters, meaning there are far fewer systems that can go wrong. Providing services are done in a timely manner, it is not uncommon for the M57 to outlive the chassis it was fitted to. From a driver's perspective, the M57 packs a hefty punch from 2000 RPM, though its 4750 RPM redline means that gear changes come quicker and more often than its petrol counterparts. Its soundtrack is reminiscent of a classic BMW straight 6, though with a deeper gurgle compared to its petrol counterparts. Its 410 Nm of torque is also a very strong point, being able to tow most small houses and spinning the rear wheels on command, though due to its heavy cast iron block does slow down the E46's usually nimble handling. This torque, however, is both a blessing and a curse due to the E46 chassis' inherent problem of rear subframe mounts cracking. As the M57 is the torquiest engine fitted to the E46 lineup, 330Ds which have been ran hard throughout their lives are more likely to have their rear subframes ripped out from their mounts on the chassis due to both the thin metal to which they're bolted to, as well as the repeat application of high torque, effectively twisting the subframe in which the differential sits until the mounting points give out. Though this is a fixable issue, it is a very involved job, requiring the dropping out of the subframe, including all surrounding accessories, as well as welding metal reinforcement plates into the chassis itself. This issue is however not exclusive to the 330D, being also prevalent with other high-power engines fitted to the E46. As for modifications, the M57 is now famous for its large potential. With stock, understressed, overbuilt internals, the M57 found in the 330D is capable of up to 250 horsepower off of a simple remap, and up to 350 horsepower with simple modifications such as an operated intercooler, 335D injectors, and a free-flowing downpipe. The variants found in the E46 330D are often more desirable than later iterations, owing to the cast iron block and sleeves that tend to be able to handle more boost when compared to the aluminium block found in post-E46 models. When fully overhauled, tuners have been able to push 400 plus horsepower reliably from these engines, with stock transmissions fitted to these units often being the first restricted to power production. In my opinion, the M57 introduced in the E46 lineup has gone on to power some of the best diesel engine cars ever produced. With its intoxicating power delivery and truck-like torque, coupled with bulletproof reliability and relative simpleness for a diesel, it can, and has, converted many a petrol puritan over to the soot side. Its all-round performance was not just appreciated by BMW owners, but by many Opel and Land Rover drivers, with Kubota even overhauling it to be used in marine applications. Simply put, the M57 can be considered to be the E46's best all-round engine, with healthy power output, great reliability, frugal fuel economy, and great tuning potential.